Good morning, good evening, good afternoon, wherever you are on this planet, people of Earth, and welcome to our SETI Live. Today, we are going to talk about one exoplanet called HD 20794D. And for this, because we love inviting people from all around the world, we have Nicola Nari with us. Hi, Nicola, how are you?
Hello, Frank. I'm fine, thanks. You?
Good, good. Where are you right now?
Now I am in Geneva, even if I usually am in Canary Islands, but I'm here for a 2 month stay because I
Okay.
need to do some projects here. But yes, now it's evening here, let's say, in
Evening
the
here.
night.
Thank you. So Nicola is an astronomer at the Lightbridge Company and Instituto de Astrofísica de Canarias, and you are
Right.
finishing your PhD. Is that correct? Right?
Yes, I'm in my last year of the PhD.
Okay. Okay. So we are going to talk about one exoplanet among 7,000 of them, which has been discovered and confirmed. And people will probably ask, why are we talking about this specific exoplanet? There is so many of them. Why this one? But before that, I have a question, Nicola. If we could
Yes.
land right now on HD 20794D with a spacecraft, what do
Yeah.
you think we will see?
Yeah, I think to answer this question, it depends a lot on the season that is now there, no? Because it can be very different if we land on the planet in the summer or in the winter, considering the kind of planet we have. It can be very cold or very hot, or maybe even warm, depending on the if we are lucky, no?
So it's
So
like Montreal. You will not know what to
yes,
wear.
yeah. You need to bring
Okay.
all the clothes that you have in your closet
Oh, the
if you
clothes you
want to
need.
go there.
Okay. All right. Talking about Montreal, welcome to our viewers, wherever you are. Let us know where you're watching us from. We have people from New Hampshire, from Sweden, which is also like Montreal, I heard. So, welcome. We're going to be talking about this interesting discovery of an analysis of the orbit of an exoplanet not far away from us. Okay, so explain to us a bit, what do we know about this exoplanet? What did you do exactly for this article that you published in ANA quite recently, in January 28, 2025?
Yes. Yes, mostly what we know about this planet is the mass and orbital period and the eccentricity of the orbit, because we detected this planet with the radial velocity method, which is a method that considers the attraction of the planet and the star, and from this we can derive like the the movement of the star, and we can derive the movement of the velocity of the star seen from us. And through this method, we only have access to the mass and the period and the eccentricity, I would say. So we know that this planet is slightly bigger than the Earth. It's like maybe a bit more than slightly. It's like 7 times the Earth of
Hmm.
the mass, the mass of the Earth. It has a longer orbital period than the Earth because it's more similar to Mars, let's say. It is on a wider orbit than the Earth. And what is more peculiar than everything is that it's very eccentric compared to the solar system planets. It's more like elongated its orbit. It's not like a perfect circular, but it's more like an
Ellipse.
ellipsoid. Yeah.
Okay, so we did not see this exoplanet. You detected with what we call radial velocity. What instrument did you use for that?
We joined the two instruments, which are ARPS and Espresso. ARPS is like an old instrument now. It's become like one of the oldest instruments in this field because it was installed in 2003 in La Silla in Chile. While Espresso is like the big brother of ARPS, even if it's younger, because it's installed in the VLT, which is an 80-meter telescope in the Paranal Observatory, again in Chile. And these two instruments are among two most precise instruments to have like RV determination in the optical. Especially Espresso can reach a precision on a single measurement of 10 centimeter per second for bright targets, as HD 2794 is. So let's say that we are really at the edge of the technological possibilities of this field to discover this kind of planet. And the observations of this star went on for more than 20 years, so it was really a long journey that I've only taken part of the at the last minute, but in time just to gather all the information. And thanks also to the work of the other people in our group, I could make, let's say, a summary of all the works and all of the data that were collected through the years with all the techniques that were developed, and create like a total, a general picture of the system where we could confirm this planet after a long time of of works on this
Okay.
system and a long campaign.
Yeah, so that's a very interesting. That when you observe a planet which has an orbital period of 650 days, I think that's the case for
Yes.
this one.
Yes.
Obviously, you need to collect data on a large period of time so you can start sensing the orbit, basically. So that's the reason you have data which has been taken since 2004, I think, or 2005.
I
And
think
this paper,
2003 also. I think so.
yeah, 2003. So quite a long time.
Yes.
Yeah, 2003. I remember I left Glacia in 2000, and they were discussing about the implementation of the ARPS instrument. So that's
Okay.
yeah,
So it was burning at that time.
exactly.
In those
All right.
days.
So with this kind of instrument, you can sense the motion of the star due to the perturbation, due to the presence of planets. And the system
Yes.
has 3 planets. Is that correct?
Correct.
Right?
Yes, it's correct. Two of them were already discovered in 2011 because they are inner, so it's easier for mostly because you need a shorter time span of observations to discover those and to characterize them, even if they're also very low amplitude. And for the other one, it started to become evident in the in a paper published in 2023. Michael Gretinier also participated in our work, and then we tried to join also the express observation to the
Ah, we lost Nicola. This is the first time something like this happened. Okay, so we're gonna wait for Nicola to come back. But in the meantime, I'm gonna say what I know about this planet and why we believe it's an interesting planet we should talk about. So this planet has an eccentric orbit, as Nicola mentioned, and it's orbiting around a G-type star. So around a G-type star, there is an area where you can have basically temperature which are compatible with the presence of liquid water on the surface. We call that the Goldilocks zone. This planet has an eccentric orbit, so it goes in and out the habitable zone. So since it's made of rocks, it may have water, liquid water, or some molecules of water, right? And you can imagine that this change of temperature will make that the planet get colder and very cold and extremely warm as it orbits around its star. So we have a very interesting system here that we can study because it's very close to us. It's only 6 parsecs, which is 18 light years away from us. And this planet, Nicola is back. I was basically summarizing. Sorry, I was summarizing the habitable zone story for this planet. So maybe you can explain to us what happened when the planet go in and out the habitable zone. Yes. What can you expect in terms of the temperature on the surface, for instance?
Yes, to define exactly the temperature, it's not so easy because we should know more about also the atmosphere of the planet, let's say. But we can make some estimation of the temperature of the planet in the case of if it was like just a rock without an atmosphere, and take this like as an example of just a working case. And we can what we can derive is like that the temperature can vary about something like 100 degrees between the moment when the planet is closer to the star and when the planet is far away from the star. So we can say that the excursion in temperature can reach even 100 degrees between, like, let's say, the moment at the when the planet is like closer to the star or when it's far away. Mm-hmm. So let's say that another thing that is interesting about this is like that you can imagine that the dimension itself of the star changing through the year because you can see the planet, the star from closer or not, so you can see it bigger or smaller. And just to have an idea, while for example for the Earth the flux is almost constant through the year because the orbit is almost circular, in the case of this planet we have like a factor 7 of difference in the flux between the periastron and the apoastron of the object. So this is a huge difference.
It's an interesting difference. It's a great laboratory to understand habitability. Let me just say hi to people watching us from the Netherlands, from Atlanta, USA, from Rio de Janeiro in Brazil, multiple people from Brazil, and from other places around the world. Thank you. We are talking about an interesting planet, HD 20794D, that was recently discovered and announced by in a paper published by Nicola Nari that we're talking with at the moment. Okay, so laboratory. We say that it's a valuable laboratory to study habitability.
Yes.
So can you explain that to us briefly?
Yes. What's special of this planet is that due to the eccentricity of its orbit, this planet goes in and out of the habitable zone. So it's not so easy to determine if the planet is habitable or not. There are like some studies about this thing, about the possibility to have like life on planets which are not constantly inside of the habitable zone. But this planet is also in a good position for us to study this with future instruments for atmospheric characterization. So maybe at some point it will be possible to determine the atmosphere of this planet, the composition, and we will be able to see if we can find some signature of molecules that are compatible with the presence of life or not. And it's not only that we can see the habitability on a general system, but on a system which has a very extreme condition, no? Because due to the variation of the temperature that we can see through the year, it can be like a very unpleasant place where to live for a human, of course, but it can be like nice to see if life can develop also in this case of extreme conditions. I think this.
All right. So it's yeah, because of change of temperature, we can expect to see a lot of differences. And the point is that this planet is quite close to us. I mentioned when you were disconnected that it's 18 light years from us, something like
something
that.
Like 19.7, I think, something like this.
Yeah, good. Well, yeah, so there is a lot of people co-author of this paper, people from various institutions around the world,
Yes.
like the University of Geneva, PlanetS, the IAC. I mean, I'm not going to name all of them. There is 23 institutions.
Yes.
So why is that? Why do you have so many authors in this paper?
First of all, because the construction and constructing and operating the instruments like Espresso or also ours, but most of the people are from the Espresso group, require a lot of expertise from different fields, so require people from different institutions. Also, the funding of this project is not easy for just one single institution because are very expensive instruments to build. And furthermore, to have like a state-of-the-art analysis, you need to join a lot of skills from different, that usually it's very difficult to have for just one person. So for example, in this paper, what was fundamental was to have like a state-of-the-art RV extraction tools that were provided, for example, by Michael Cretinier, who was a former student in the PhD students at the University of Geneva, and now it's in Oxford. We also use statistical methods to validate the planets that were developed by another researcher, Nathan Hara. We needed to collect data from different programs in order to reach the number of observations that we required. And so we can say that only big collaborations can bring all these things at once and make it possible to study the edge of the sensitivity limit of the instruments, let's say.
Yeah, because if you read the paper, I recommend you have a look at the paper if you have an interest, people. That you see that one of the issues is that also to identify the signatures coming from the variation of the activity of the star, which has been also a significant part of the study. There's different models which have been used for that. Then you instruct the signal, which is not obvious into the data. And then when you have the signal, you try to fit with different parameters. There is 3 planets of different variation. I really think it's amazing how astronomers are capable of doing such a study now, using all this modeling and all this mathematical algorithm. And if people always say, well, math is useless, this is a very good application of where mathematics is not so useless. Without our knowledge in data processing that we acquire over the past 20 years.
It's very useful, and at some point it's very fundamental, like to have the best correction and also to apply techniques that are always refined through the years, that requires like a deeper and deeper knowledge of the statistics, for example, or machine learning, this kind of things. So
Yeah.
there's really a strong background behind these discoveries.
Yes, for the young people, don't listen to what social media tells you. Math is useful. Okay.
Completely agree.
So what's next? What's the next step? Now we know there is 3 planets, one of them entering in and out his habitable zone. It's not that far away from us. So what do you think we're gonna do with this?
I think the natural next step is to wait at this moment, in the sense that we need to wait like some years in order to have the next generation of instruments that can characterize the atmosphere of these planets.
Mm-hmm.
Because, for example, there are new concepts and new projects that are going to become reality in maybe in 10 or 20 years, like the Habitable World Observatory, which is like a space telescope from NASA that should be able to investigate the atmosphere of the outer planet of the system. This will bring some insight on the composition of the atmosphere, if the research will be done, and thanks to this we will be able to maybe infer something about the habitability. But even if it's not directly the research of a biosignature, it can be just like the hint of the presence of some molecules that could be already like an interesting discovery for a planet that is orbiting the star in the habitable zone of a sun-like star, I think. So we need to wait and keep working on the technology in order to have the best instruments to move from the detection to the characterization of these planets, I would say.
Okay. We're going to take some questions from our audience. We have one already here. Someone asked if there is any chance we can analyze the atmosphere of this planet, even though it doesn't transit the star. That's some fun.
Yes, no, it's a good question, because in fact what we do nowadays is to analyze the atmosphere when the planet transit. In the case of HC 2794, we don't see signature of the transit. We don't think that the planet is transiting the star. But as I was saying before, there are new concepts for the studying of the atmosphere of the exoplanets, both from the ground and from space. And fortunately, we are like also lucky about this, because this is a combination of the characteristic of the planet and the characteristic of the distance of the system compared to the Earth. This planet will be possible to investigate it with the next generation of instruments, like, as I said, HWO, but also LIFE, which is another mission financed by ESA that is supposed to fly in 2050, something like that, if it will be approved. That can also characterize the atmosphere of the planet. And so it's true that at the moment it's very hard, let's say, in the close future to characterize this, because there is no transit. But this doesn't mean that in the future it will not be possible to also say something about the atmosphere with the new generation of instruments.
Yeah, so we are developing on the ground as well adaptive optic systems that will be capable of detecting super Earth. There is projects like this for extremely large telescope, like the TMT, the ELT, and so on.
Like Andes, and it's a spectrograph that is going to be built in the ELT that maybe can also do these planets. It's a bit more difficult for Andes because they're like not so bright, but in principle it's not completely invisible. So we can also hope in Andes, yes.
Yeah. The contrast is the problem here, because these are super Earths orbiting around G-type star.
Yes.
So we're talking about something which is a billion times fainter, probably, than the star. We have people joining us and mentioning from Wales, from Seattle. Oh, that's Margaret. Hello, Margaret. From Alabama, from Sarajevo. Welcome. So we are going to take a few more questions. I see there is 2 more popping up here. One more. How long before we're able to discern axial tilt of this world to further understand the possible seasonal effects? So we'll be able to see if this planet is tilted one day. And how?
This is something that is out of my expertise. I don't know very well, like if this will be possible or not. I
I
think
have
this
an idea.
I think this is very hard, to be honest, to understand if the axis is tilted or not, to see if there are like seasons on the planets. But I think that in the case of this planet, the seasons are like, if we consider season not just as the days being longer or shorter, but being like hotter or colder, they are like natural season brought by the eccentricity, no?
Yeah.
Even if the planet has an axis which is like completely aligned to the stars, so the duration of the day is the same through the year, the flux would be so different from the periastron and the apoastron that there would be like a difference in the temperature of the planet, which is probably a stronger effect than what would be brought by the axial tilt, I would say. Because as we can see, for example, in the Earth, there is not an extreme difference between the winter and the summer comparable to what is the difference between the apoastron and the periastron for this planet. So I suppose that the answer to the question is no, but still there is something similar to seasons there.
Yeah. So one possibility would be in the future by looking at the magnetic field of the planet.
Oh.
In this case, if the planet is tilted and the magnetic field is more or less aligned with it, we may be able to do that. But the magnetic field of planets is not always aligned with the spin axis of the planet. It's the case for Earth plus or minus 15 degrees, something like this, if I remember. So it's a very complex question. I have a question to entertain a bit here. When I used to work in observatory like La Silla and so on, we used to discover these major things. And yes, we dislike those names, HD 20794D. And we used to nickname stuff. So did you have a nickname for this one? Or we were just like every time you were talking about this planet to your boss, to your advisor, to your colleague, you were saying HD 20794D? Or you have a name?
To be honest, I always use the catalog name like HD2794D, but I know that this star is like known in the field as Pepe star from the first article on the planet from Francesco Pepe. He's also in the Observatory of Geneva. Now he's the director of the Observatory of Geneva, and he has done the first work on the star, discovering the two inner planets at 18 and 89 days. So if you prefer, you can call it Pepe star D instead of HD2794D.
Is that the PI of Espresso you're talking about?
Yes.
Oh, okay.
He's
All
also
right.
the PI of the instrument.
Yeah, I met him long time ago when I was working there. Okay. We're gonna take I have a final question for you. So you can travel, okay, 50 years in the future. What do you think we will discover from about HD of the Pepe star D? That will be the most interesting for astronomer or for people at large. What will be the future big discovery on this planet?
Well, my wish, let's say, that what I would really like to see is that we will be able to discover something about the atmosphere of this planet. We will be able to say something about the composition and maybe some biosignatures, but even if this will be out of our capabilities, I don't know very well if this is going to be or not. I hope that in 50 years we will be able to say something about the atmosphere of these and other planets of similar mass and similar position compared to the star, let's say in the habitable zone. This would be the great achievement that we still have to do about this planet, I would say. This is the next step to discover what's left.
And to do that, we need to build space telescopes, probably, like you mentioned, at LIFE or Habitable World Observatory. We will need to invest in developing those technology that are capable of imaging Earth, super Earth, exoplanet. And
yes, it requires.
We're not that yet, but it's something we know to do. It's just a question of time and money.
I think that with the funding, it will be just like technological development, and they would come.
Aye. Well, I do remember when people used to say it's impossible to discover planets smaller than Jupiter, or it would be impossible to image planet around stars. And now we are doing it, and young people like you publish papers showing that it's durable and we can characterize them and find about those exoworlds. So yeah, technology is
Yeah,
progressing and going fast.
yeah. Probably in
All
20
right.
years we will think the same. Oh.
Thank you. My dog just woke up. Thank you very much, Nicola, for your
Thank you for
time.
your hospitality.
And yeah, I'm sure we're gonna have the opportunity to talk to each other in the future.
Yes,
Thank
sir.
you to our viewers, wherever you are. Remember, this is the SETI Institute, SETI Live. We are a non-profit organization. You can make a small donation at seti.org Give Now, as it's popping up on the screen as I speak. And you can also visit our website. We notice that we have a lot of people who join us every week. Guys, if you want to share the wonder of these programs, please share it on your social media. Let your friends know about it. Write some comments at the bottom of this video on YouTube or whatever platform you're using. We read them, we comment, we answer to your comments. Sorry. So yeah, take the time to share the wonder of space exploration. And if you make a major donation, maybe we will have enough money to invite Nicola to come to California and build
Why not?
the large telescope that will one day discover life on the wonderful planet called HD 20794D. Thank you again. Bye-bye.
Bye. Thank you.